Okay, today we are going to continue with our quadrilateral talk, and we're going to move into parallelograms. Parallelograms have 4 theorems, and we're going to talk about what a theorem is in a moment. 4 theorems regarding them. But first things first, make sure that you have, I'm going to use 2 highlighters and a pencil today. Okay, make sure you have a good eraser. And if you want to, you can print this page off. It was attached in School Loop so that you can have it for your notes. And let's get started on our prior knowledge vocabulary. A parallelogram is a quadrilateral with 2 pairs of opposite sides parallel. Congruent, same shape and size. Another word for that is equal. Bisect means to cut in half. We're going to use that word today. And a theorem. A theorem is a math fact that has been proven. Okay? So let's get started. Theorem 1 states, if a quadrilateral is a parallelogram, then opposite, and I'm going to abbreviate, sides are congruent. So as I have my parallelogram right down here, I'm going to move it up. I'm going to label my parallelogram A, B, C, D. I'm going to make my markings to show that it is a parallelogram. And then I am going to make my markings to show the congruent sides. So opposite sides are congruent. So AB is opposite of DC. And the statement there would be AB is congruent to CD. And the reason why you say that, if you take this shape and you were to rotate it, C would wind up in the same spot as A, D would wind up in the same spot as B. The other sides that are congruent to each other would be B, and I'm going to put 2 slash marks there, BC and DA. So I would say BC is congruent to DA. And though that is theorem 1 for parallelograms. Okay, let's keep going, and we're going to look at the first example, or the second example, really. It says solve for x. So as I look at x, I see that I have an x there on SV. And I also see that SV is congruent to TU. So, solve for x, 2x minus 8 is equal to 8. And then I'm going to add 8 to both sides. I'm going to solve this equation. Divided by 2. And I find that x equals 8. It asks me to solve for 8. I have found that x equals 8, so I am done. But that's not always the case, as in this next question. It says find UV. So I have to highlight UV, or at least identify where it is, and realize that it is 3x minus 7. So I'm going to go UV is 3x minus 7. And based on the theorem, theorem 1 says that opposite sides are congruent. So I'm going to go to its opposite side, and I know that congruent means equals. So I'm going to go 3x minus 7 equals 2x. And then I'm going to solve this equation. There are a lot of different ways to solve this equation, but I'm going to solve it this way. I'm going to subtract 2x from both sides, and I'm going to get x minus 7 equals 2x minus 2x cancels out, you get a 0. Then I'm going to add a 7 to this side and to that side. They cancel out, you get x equals 7. But I'm not done, because it is asking me to find UV, and UV is 3x minus 7. So the way that I'm going to do that is, if I know that x equals 7, I'm going to take that and I'm going to plug it into 3x minus 7. So I'm going to go 3 times 7 minus 7, and 3 times 7 is 21 minus 7, and that will equal 14. So UV is equal to 14. Sorry for writing in lots of different places and spaces, but that's your answer. UV equals 14. Okay, and those are sides. Opposite sides are congruent. Now we're going to look at Theorem 4. In Theorem 4, it says if a quadrilateral is a parallelogram, then diagonals bisect each other. So I'm going to label M, N, O, P. And this point where they intersect, where the diagonals intersect, I'm going to label E. And it says diagonals bisect each other, which means they cut each other in half. So I have ME is one half, OE is the other half. So ME would be congruent to OE because they cut each other in half. And over here, I have PE, I'll put two markings on, is congruent to NE. And I'll put two markings on that. Okay, so that tells us about the diagonals. So let's put that into play. It says solve for x down here. I know by looking above that, and when I label them, I'll label them again. M, N, O, P, and then I'll put an E in the middle. Remember that PE is congruent to NE. So PE is 2x plus 1, and that would equal NE, which is 15. Solve for x. Divide by 2. X equals 7. And we are done because it asks us to solve for x. Okay? Now, like on the last one, they're not always that simple. Let's look at one that's a little bit more difficult. Just a little bit more thought-provoking, not difficult. It tells me that YW equals 24. YW equals 24. So I know that YW is 24 units. Then it tells me that LW right here, is equal to x plus 6. So I'm going to label that. And now it asks me to, I'm going to ask you to solve for x. So x plus 6 is LW, which is half. So now I need to figure out what half of YW is. Well, if I know what YW is 24, half of that would be 12. There's our equation. Now we're going to subtract 6 on both sides. And you get x equals 6. And we are finished because it asked us to solve for x. Okay? So our answer is x equals 6. I hope those explanations made sense to you. I know I went a little bit quick, but I would like you to get them and to use your practice page right there. I'm going to zoom out a little bit. And I'm going to put some practice problems that I'd like you to try. These 6 problems, these are the video notes theorems. This is also attached, and you can print it off, or you can copy down the pictures. Questions 1 and 2, they want you to state the theorem. So as you're doing this, write which theorem you're using, either 1 or 4, depending on if you're dealing with a side or a diagonal. Then solve for x. Number 3 and 4, it asks you to find a side. 5 and 6 asks you to deal with diagonals. Okay, good luck. If you have any questions, watch the video and bring it in tomorrow. Talk to you later.